So good morning, everyone. So my name is Yergeau. I am the clinical research coordinator working with Dr. Braverman at the McGill University Health Center Research Institute. And I would like to thank you for giving me the opportunity today to give you an update on the mental history study on peroxisomal disorders. I will start by giving you a general update on the study, and then after I will talk about the specific project that we did in collaboration with Dr. Masumi Bose. So I'm going to start with giving you an overview of our methodology for the natural history study. So what we do is that after a patient is admitted, we obtain the medical records directly from the hospitals with the authorization of the patient or the parents, of course. And I just want to acknowledge here that, sorry, I have trouble with this figure. Okay. We have had the chance this year to have help from ST Escovitz, who was helping us with this aspect of the study of enrolling patients and collecting medical records. Thank you, ST, for helping us make the study grow even more. Once we collect the medical records, we put the pertinent data in a homemade Microsoft Access database. And that allows us to be able to standardize our data, to be able to extract it more easily and make analyses. And the purpose of this study is really to better understand the disease progression and its huge variation. And I also wanted to say thank you to Nancy for this great introduction because it really sets the stage for my presentation. And the ultimate goal is to be able to improve the management guidelines for these patients for them to have optimal care, as well as ultimately being able to determine reliable and good endpoints to be able to evaluate efficacy in the future clinical trials. And so here's an update of the evolution of our natural history study in the last few years. So around 2015, 2017, we obtained ethics approval to get going. We created this access database, and we, of course, recruited patients. In 2018, 2019, this is really when we started to grow a bit more, and our database and our study became more known in the community. And we were starting to be able to collect and analyze data and continue recruiting patients. And it's really more in the last 2 years that we started to be able to analyze all of this data and started to put together manuscripts. And so we have published in the last few years a characterization of hearing loss and thyroid spectrum disorder. We also recently published a MAC16 case series that Dr. Braverman talked about. And we also very recently published the characterization of severities based on clinical findings. And this is what we're going to talk to you about today more in details. And just so that you know, we're also preparing some material on describing the neurological spectrum in ZSD, as well as liver disease, vision loss, and we're also preparing growth curves. And we're putting together also, we're preparing an eventual prospective vision study for Alzheimer's spectrum disorder, and we're still recruiting patients in our study currently. And this is the number of participants in our natural history study that we have recruited each year. So you see the year at the top and the number of patients on the bottom. And at the very bottom, there's the cumulative number of patients. So we have, at the moment, a total of 222 patients in our study. And out of these 222 patients, we have collected medical records of 119 patients. And this is the demographics of this 190 patients, first by geographical location. As you can see, most of our patients are from North America, and most of which are from the United States. But we still have 14 patients from Western Europe, 7 patients from Eastern Europe, 5 from Middle East, 5 from South America, 1 from India, and 6 from Australia. And this is a distribution of the number of patients per age groups. With the red bars, the colors are not very good. The red bars are showing deceased patients, and the gray bars are showing currently living patients. So as you can see, most of our patients are approximately equally distributed between the age of 0 to 20 years old. And we have the largest proportion of deceased patients in this 0 to 1 year age range. And this is the demographics of our patient population based on genotypes. So most of our patients have a peroxisomal biogenesis disorder, but we also include patients, a few patients with single enzyme defects. And so for PBDs, most of our patients have Warrior spectrum disorder, so 161 patients. We have 6 patients with RCDP. And out of the ZSD, we have 27 patients with more of a severe clinical picture that Dr. Braverman talked about, with the congenital malformation, the brain malformation, and the renal problems, and the shortened lifespan. We have 134 patients that are mild intermediate ZSD, most of which, so 87, have mutations in PEX1, and most of them have this common allele that we talked about, this G843D allele. And we have 19 patients with PEX6, and then 8 with PEX16, 5 with PEX10, and then the other PEXs is 1 or 2 patients. And for the single enzyme defects, we have 17 patients with deep bifunctional protein deficiency, 6 of which have a severe picture, and 11 with a more mild intermediate, and a few with these other single enzyme defects, for a total of 190 patients. Okay, so that was a general overview, and now I want to talk about more of this project that we did in the last year and a half that we put together. Really, that was a characterization of severity in Zollinger spectrum disorder based on clinical findings and biochemical findings. And so the way we did this project is that we did a review of all the data that we had in the natural history study. So that was by our team, but we paired up with the Sumi's team, which they did a literature review of all of these findings, and we put this together to have a more powerful thing to show. So I would invite Masumi to join. We can either join me now, or I have a few slides as you wish. And also, I just want to do an acknowledgement, say thank you, to David Cuthbertson, who did the statistical analysis for this project with us. And so, as I said, the purpose of the study was really to be able to determine or to evaluate if we could determine severity only based on clinical findings and biochemical findings. And so I'm going to show you the methodology for the medical chart review part, the one that we did. So what we did is that we extracted the data, the clinical data that we had from our database, but also we went back into some medical records to have a more comprehensive view of all the data. And what we did with this is that we produced what we call a data synthesis matrix that is represented in a table like this, in which we reported presence or absence of each clinical finding, as well as the first age that was reported in the medical records that we could find. We also reported survival or current age, and also a couple of peroxisomal biomarkers. And so in the data synthesis matrix, each column was representing one clinical finding or one biomarker, and each line was a different patient. And we started with, for the natural history study, we started with 150 patients. And what we had to do after this big table was done is that we had to do a preliminary severity designation, because we wanted to see if the clinical findings separated significantly between the 3 severity groups that were mild, intermediate, and severe. So we had to come up with a way to do an initial evaluation of severity. And so this is what I'm showing you here. So this is a kind of a decisional flow chart that we put together to be able to ask whether each patient was severe, intermediate, or mild. And this was based on known and published features of ZSD, and also our accumulated knowledge with the natural history study. And so the way we worked that is that we took one patient and we interrogate for the features in the red box first. And if the patient had at least 4 of the following features, including neonatal seizures, hypotonia at birth, failure to thrive, age of death below 2 years old, polymicrogyria or brain MRI or autopsy, bilateral renal cortical microcysts on ultrasound, and chondrodysplasia punctata on hips and knees on X-ray. And if the answer is yes, then we would classify this patient as a severe patient. If it was no, then we would interrogate the features in the blue box. And so we would ask if the patient had at least 2 of the following features, including adrenal insufficiency, gastroesophageal bleeding, G2 feeding, inability to walk independently after 2 years old, and inability to communicate with at least 2 3-word sentences after 2 years old. And if the answer was yes, we would say this patient was intermediate, and if it was no, then all the rest of the patients were classified as mild. And so what we did is that we added this piece of information in our data synthesis matrix. And so when we did this, we were then ready to do the statistics and see if something would come up as significantly different. And so the main questions that we asked was whether the prevalence of clinical findings was different between the 3 severity groups, whether the ages of onset for each clinical finding was different between the severity groups, and whether the levels of peroxisomal biomarkers were different. And this is the first part of our results, showing the clinical findings we looked at. So each row here is a different clinical finding, and in the table you are looking at percentage of patients with the finding, and in parentheses is the total patients that had an assessment for the clinical finding. And you have the 3 columns for severity, severe, intermediate, mild. And the second portion of this table to your right is the ages of onset. So we'll start with the prevalence of findings. So what we saw is that, for example, a seizure disorder, abnormal EEG were more prevalent. Oh, I forgot to mention something, sorry. Here in the table, wherever you see asterisk, it represents significant difference in prevalence between severe and intermediate patients. And the little caret sign here represents significant difference in prevalence between mild and intermediate patients. And so what we observed is that for seizure disorder, normal EEG, we saw an increased prevalence as severity increases, while for presence of any brain MRI abnormality, there was no significant difference across the severities. Hypotonia was similarly present for severe and intermediate patients, but significantly less prevalent in the mild group. Interestingly, for the gastrointestinal findings, so for all of them, including feeding difficulties, failure to thrive, gastroesophageal reflux, abnormal liver functions, or abnormal liver structures, we saw a significant difference between mild and intermediate, so it was less prevalent in mild patients, but it was not significantly different between severe and intermediate patients. The other clinical findings that we looked at that were different included vision loss, renal cortical microcysts, cardiac abnormalities, and bone fractures. For all these 4, we saw an increase in prevalence as severity increases. Only adrenal insufficiency, we saw actually it was more prevalent in the intermediate group compared to the severe group. And I should say we looked at other clinical findings that are not in this table, and the reason why we did not include it in the table is that because there was no significant difference across any of the severity groups, and this includes dental abnormalities, kidney stones, low bone mineral density, and ataxia, and I might be forgetting some others. So we observed the presence of the symptom at earlier ages as the severity increases. So what we expected. Of course, there were a couple of exceptions. For example, if you look at bone fractures, you can see that it was at an exact same median age for intermediate and mild patients. And cardiac abnormalities also for severe and intermediate patients occur at around the same age. Then continuing with table, we also looked at a couple of developmental outcomes. So what we observed is that there was a significant difference for all of them between mild and intermediate patients. And for global developmental delay, not sitting independently, walking with support, no words, 2-3 words together, and intellectual disability, it was more prevalent in the intermediate severity group compared to the mild. While walking independently and doing full sentences and putting 2-3 words together were more prevalent in the mild group compared to intermediate groups. For the peroxisomal metabolites, this is showing the number of patients in which there was a decrease in plasmalogens. So it's not looking at the level, but just whether it was decreased compared to the normal range. And we saw that it was significantly more prevalent, in severe patients compared to intermediate compared to mild. And we also looked at lifespan, so whether the patient passed away before the age of 2 years, almost all of the severe patients did, and none of the intermediate and mild patients that passed away before the age of 2. Then we looked at the level of the peroxisome biomarkers that we collected from the medical charts. What we observed is that for the C26 very long-chain fatty acids and the bile acid intermediates, C27, DHC, and THCA, their levels were increased as the severity increased significantly, while for the plasmalogen levels, they were significantly more decreased as the severity increased as we expected. But we were pleased to see that it was very significant for all of these markers. Okay, so then the next step with all of this data, so this was more of a kind of a descriptive data of all we collected from the medical records, but then we wanted to go a step further and see if we could do a model that would allow us to predict a specific severity based on the clinical findings for a patient. And so we ran what we call a multinomial logistics model, and this allows to calculate this probability. And so when we looked at all the clinical findings that we have collected, not a lot of them were robust enough to be able to run the model so that it could work. The only 4 that allowed the model to work were these 4 symptoms or clinical findings that are seizure disorder, abnormal EEG, bilateral renal cortical microcyst, and cardiac abnormalities. So what you're seeing here is a depiction of the results of this model. So on the y-axis, you see the probability and percentage of belonging to a specific severity category. And on the x-axis, you see the number of symptoms among those listed that the patient has. And the red bars represent severe patients, the blue bars are intermediate, and the green bars are mild patients. And you will see the same color code for the next coming graphs. And the error bars here represent confidence intervals. And so what we see is that the more symptoms you have along this list, if you have all 4 symptoms, the probability of belonging to the severe category is increased. And conversely, if you have none of these symptoms, then you have the highest chance of belonging to the mild category. What I want to point out with this model is that the fact that we only have 4 clinical findings we can work with, and the fact that the confidence intervals overlap quite a bit makes the results makes the prediction a bit hard to interpret. So we have to take this with a grain of salt. In order to make the model more reliable and more robust, we would definitely need to include more clinical findings. And therefore, we will need to be able to get a more comprehensive data set on each patient to allow us to do that. Similarly, we did run this multinomial logistic model not only on the clinical findings, but also on the biochemical marker that we collected. And the only marker that was robust enough to allow the model to work was the C26 very long-chain fatty acid. And so this is the same idea here, where on the x-axis you have the probability of belonging to a specific severity category in percentage. And on the x-axis, you have the level of plasma C26, a very long-chain fatty acid. And so what this graph shows is that is the same color code that you saw previously. So as the level of C26 increases, the probability of belonging to the severe category increases. And conversely, as the level decreases, the probability of belonging to the mild category increases. I should say though, the dotted lines around the main curve are the confidence intervals. So you can see that as you go really high, these confidence intervals becomes really large. And I also want to point out that there are areas in this graph where you could have equal or close to equal probability of belonging to 2 different severity groups. So around 1.1 micrograms per mil, you're about 50% probability for mild and intermediate. While around 5.6, it's 50-50 for mild intermediate and severe patients. And so what I wanted to say is that this suggests that the C26.0 levels are a good predictor of severity. However, in the gray areas where there's a lot of overlap, or there could be equal probability of belonging to more than one severity group, then we would probably need to add maybe other biomarkers or the clinical findings in the model to make it all one better predictor. Yeah, so that's it for the part on the medical chart review. So I will let Ms. Sumi talk about the part on the literature review. So thank you.